Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 5D. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GS Scholastic LLP, it is a great pleasure to welcome you to the 10th International Conference in Smart Trends in Computing and Communications, SMARTCOM 26, Pune, India. The 10th edition of this conference is being held in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19 till the 21st of January 26. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. This another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started with our session, I'd like to introduce you all to our session chair. We have with us Dr. Shalini Puri, who is a research professor in the Department of Information Technology at Manipal University, Jaipur, India. With 20 plus years of teaching experience and 11 years of research experience, she has published 30 plus research papers and actively participates in national FTPs, workshops, and training programs. Her research interests include machine learning, image processing, pattern recognition, and artificial intelligence. We welcome you, ma'am. I'd like to start with our paper presentations now. Our first presenter, Suchitra Karba, with the paper titled A Survey of NLP Approaches for Climate Change Sentiment Analysis in Global and Indian Contexts. Ma'am, if you're ready, then you may start with the presentation.
Yes, sure. I'll share my screen. Please
Sure,
let
ma'am.
me know if it is visible.
Sure, ma'am.
Okay, good afternoon, everyone. Today here, I'm going to discuss few points that I have surveyed under the climate change sentiment analysis, different NLP approaches, and I have taken a context that is global and Indian both. So the title of my paper is Survey of NLP Approaches for Climate Change Sentiment Analysis in Global and Indian Context. Now, talking about background and motivation, why I have selected this particular topic. Currently, change has become one of the most recognizable global issues of 21st century, and it affects the agenda of political sphere, the economic planning, scientific innovation, and even the everyday life of a human. So, climate-related communication has become more dynamic, political, and emotive. Now, when I talk about sentiment analysis and climate change, different policymakers make the policies based on the climate change, forecaster forecast based on the previous knowledges or the current scenarios. But when it comes to the applying the policy, unless and until every person or the people are involved into it, it is not possible to identify the success of that policy. The involvement of common people is most important thing in it. That's what I feel, because they are going to follow the policies generated by or prepared by policymakers. So we have to identify, or we have to gather the data we have to gather the opinion of even public to shape the policies and to help the governance too. So where can I get this data? That is what my important point. So social media, news outlets, scientific discussions, and some policy deliberations also form a significant part of this working of a social opinion. And social media has the power. We know the social media has the power to change the collective behavior, even promote governmental and institutional action, and it helps us to shape the perception of even climate issue. So to identify these sentiment patterns, whatever posted on the social media, the important approach can be a natural language processing approach. It can identify not only the polarity, but also the stance, emotion, ideological framing, and implicit attitudes that are contained within the climate discussion that is posted on the social media. So over the last several years, NLP climate change communication has progressed beyond simple lexicon-based code to deep learning and even transformer-based models that can understand context, subtle semantics, and socio-cultural diversity. So there are when we talk about how it is posted, the distinctive linguistic features are also seen within it. So social media and news act key plays an important role while considering the data values within climate change analysis. So what is the basic objective of this study? uh, because social media posts are important data sources for this particular survey, and the social media post can be in different forms. They can post in the form of different textual paragraphs, they can post emojis, they can post images, they can post videos. The different modes of uh, mm, information is available on the social media. So the most important thing is how I can analyze that particular data on a social media. So for that, NLP techniques are the most important thing can be used. So how it is evolved and how this data sources are analyzed. So it starts with the NLP techniques for basic sentiment analysis. Then the next evolution is few researchers have used machine learning algorithms along with transformers based approaches. And how it is evolved, that is what my important focus. And not only the evolution of NLP techniques and till transformer based approach, but how uh, data sources also the data values are posted by Indian people and the global people, and the focus of posting it on the social media is different. That also needs to be taken into consideration. And based on this, what will be my final challenge key research gap, and what will be my future direction for the research? That is what this particular paper flow gives talks about. So this is what the objective of my study: to identify what different natural language techniques are used, the evolution of different techniques in the form of machine learning, transformer based, and the focus global and Indian global focus in global and Indian context, and what are different research gaps. Now talking about, because it is dealing with climate change, why and what exactly is the climate sentiment analysis? Now this term is a method of making use of natural language processing technology uh, to analyze attitude, reactions, even emotional stance of common people, communities, in term of environment concern. It is not only about only positive and negative polarity, but it also addresses more general communicative tasks like stance recognition, emotion recognition, opinion recognition, even arguments. So polarity analysis determines whether the writing is advocative, critical, or neutral in discussing climate issues, whereas the stance detection identifies position of the writer with regard to the climate actions. Now, the analysis of emotion identifies psychological moods like fear, hope, anger, urgency, frustration, that can be implicitly present in climate discourse. Now, these dimensions of sentiment are also used to reveal patterns of climate communication in social media, news media, etc. So in addition to detecting misinformation, or sometimes the people can post the information that is misguiding, that can be treated as misinformation. That is also an important in this context. So and as I said, not only textual format, but they can post images, emojis, videos, and also multimodal extensions are also needed into it. So collectively, these analysis activities allows us to measure the perception of population, analyze the communication tactics, analyze polarization of ideas, and promote evidence-based climate policies, which is why sentiment analysis is an essential aspect of climate informatics. Talking about uh, the different methods or approaches used for this. The first one, the most basic approach was the traditional NLP approach. So the basic approach under NLP was lexicon based sentiment score. It is one of the first and most understandable method of analyzing climate oriented attitude in text context. Now, these techniques are based on pre-established dictionaries in which words or phrases are given sentiment values, which are usually positive, negative, or neutral. And again, the next part, examples of this lexicon based are the tools like SentiWordNet and Weather. The SentiWordNet have been used to expand sentiment annotation in WordNet. Weather, which is optimized to work with social media, and it includes rule to deal with intensifiers, negations, punctuations, emojis, and slang. Now, these are used for Twitter and database or data sources. So lexicon methods are computationally efficient, and human readable, but they usually have problems with situational ambiguity, sometimes sarcasm, and metaphor. Now, next comes statistical machine learning methodologies. These are used to classify sentiment based on the data. SVM, naive-based logistic regression, random forest algorithms are these are few approaches that are used to learn sentiment pattern using labeled climate discourse based on decision boundaries instead of predefined sentiment dictionaries. Now, next, SVM is specifically used for high-dimensional text representation. Naive-based is uh, used when short messages are posted on climate topics. Logistic regression is popular for baseline excuse me. Random forests are used for long relationships and feature extractions. Now, next come the engineering approach, where bag of words is the text representation that represent text in the form of unordered number of words, which is simple and computationally efficient. The next was term frequency inverse document frequency IDF TF-IDF. It is a better performance indicator than BOW because it assigns weights to words depending upon their significance in a document as compared to the significance in corpus, and it allows emphasis on discriminative climate related words. Now, the next is n-grams. Bigrams, trigrams, or n-grams provide local context through word sequences of short length. Now, the feature engineering approaches do not have semantic knowledge and do not deal with metaphors. Even it do not we deal with implicit emotion, sarcasm. So they are significant because they are easy to implement, interpretable, and show good performance when used together with statistical learning. Now, next is deep learning approach. After traditional NLP, the deep learning approaches are added into it, like CNN, combination of RNN and LSTM. Now, CNN is mostly used for local sentiment patterns. RNN and LSTM models are used for temporal sentiment trends. Now, it is mainly used to improve interpretability, but it needs large label data set. This can be an disadvantage of it. Now, next approach used was transformer based model. So mostly birds are used here, and birds provide bidirectional encoding which enable models to learn semantic connections between the entire sentences as opposed to local context. This is an essential skill that is essential in the interpretation of subtle expressions of climate that use uncertainty, sarcasm, framing policies, and science. The Cybert is used to fill this gap. Now, since it uses scientific literature and is suitable to analyze climate research articles, documents on environmental policies, and commentary by
No,
experts. ClimateBird is directly trained on climate related text. This is a special bird
but I'd
or
like to remind you of the time
dedicated
limit.
bird. Oh, it's 9 minutes over. Okay. So, transformer based models are climate bird, cybird, and indobird. These are specifically designed birds for special data sources or data values. Indobird is specifically for regional linguistic patterns. Now, GPT based generative models are uh, mostly uh, these allow performing classification as well generative reasoning processes. It is good at generating detailed rationalization of sentiments. Now, the important is, if I talk about Indian context, we have multiple languages, and post people can post their opinions in varieties of languages and their dialects: Hindi, Tamil, English, Bengal, anything. But we need something, a transformer which can work in multiple languages. That is, cross-lingual transformers are important, are required. So there are few XLMR, MBERT, MT5, Indigo. Indic is cross-lingual transformers designed by few of the researchers. Now, talking about the few research papers that I have studied or gone through, surveyed, this is what the summary of all those, what different models are used on what different data sources, because data sources are most important because we have to scrap it from social media. What type of task is performed by each of the methodologies and the limitations of each of them. So most of the time, the data source used, social media data source used, was the Twitter, sometimes Reddit, few new news blogs, etc., and sometimes reports, scientific reports, documents too. So based on that, using different methodologies, semantic stance and emotion analysis is done, and the limitations are given over here. Now when I talk about designing new technology or having something to identify climate sentiment analysis, I need to talk about the context, either it is a global context or Indian context. So global context specifically deals with the mitigation policies and technological advancement, but in Indian, the focus of India will be on the livelihoods, or on the monsoon variability, air pollution, heat waves, or scarcity of water, likewise. So, in this case, if I talk about Indian context or in global context too, linguistic approach is also important, multilingual approach, and even they can have uh, uh, by identifying their cultural differences, we should have, or there is a need for culturally aware NLP model that can handle multilingual communication, regional priorities, and even distinct emotional framings of climate discourse. Now, data source, as I said, it can be taken from different social media platforms like Twitter, Facebook, Instagram, and which provides me a real-time user-generated and multilingual climate discourse. Sometimes it can be taken from different news media, both international and Indian. Even scientific articles and policy reports contribute expert-driven technical and general communication. Uh, and talking about key challenges, because it is taken from social media, it is possible that people are writing some information which can be misguiding. Sometimes they are posting in their anger or happiness, that may lead to their biased opinions. Even sometimes they post information that is not exactly correct, that is misinformation. So sarcasm is also the important thing, that is they have posted something, we feel it is in positive manner, but it actually the use of positive words that is in negative manner. So key challenges are identifying misinformation, sarcasm, metaphor, and noise, or sometimes incorrect data values too, or biased data values on the data sources. Now talking about all those things, after studying all those things about what advancements are done and where we can find data sources, I found that the main research gap is in, we don't have a standard data set over here. So we should have, there is a need for further study or research, there is a need to have a better annotate data set. The sarcasm and metaphors that can, after analysis, that can lead or misguide us in further research. So better handling of sarcasm metaphors are needed. If, because multiple people are posting on with their regional languages, multilingual climate corpora is needed, and hybrid models are to be designed, which should be a combination of NLP and climate science, because some words are specifically used in climate region only. So at the end, I wish to conclude that NLP for climate change has evolved significantly. The flow I have given, how it is evolved. Currently, transformers play an important role. This is the state of art. We need to have context aware and multilingual models, but designing is very crucial. And for future work, it should focus on robust data set and interpretability. These are few references I have kept, how literature is surveyed. Um, there are 13 papers placed over here. Uh, Thank you very much. If any question, please.
Yes, ma'am. Good presentation.
Thank you.
Yeah, I have some queries that you told that standard data sets are not available. So you are talking only about the climate change sentiment analysis or about the linguality of the data sets?
Both, ma'am, because few data sets, those are present only, structured and unstructured, both type of sets can be present. That is, if a forecaster is um, publishing something that is in particular format, if I am, as a common people is posting something, I can write paragraph in any format. So that is unstructured data. Even if I am Marathi or somebody is Bengali, so they can post in different languages. So these different varieties are present over there. And for globally, they have scrapped some data values from the Twitter and Reddit that is used earlier for different models. But because timely social media platforms, the people are keeping on posting different paragraphs or their opinions on social media platforms, the data values are dynamic. So we cannot say this is the fixed data source present over here. So Twitter, Reddit, we have to use scrapping tools, and we have to scrap the values from it, and we can get the data set based on what type of model we are going to design.
Okay. And you have mentioned the term global and Indic, right?
Yes,
So,
yes, yes.
right. So, have you like searched about the non-Indic scripts as well, or non-Indic languages? I mean, you made some chart or something like, because you should know the how many languages are being used through, across the world, or maybe not. If we are talking about the Indian languages, so there should be some mechanism to find out the languages as well, because I have researched on languages. My field was language only. So I have
Mhm.
also observed that there were around more than 750 languages in India as well.
Yes,
So
yes.
now gradually the things are being changed. So I mean, I one of my suggestion is you just should go through the number of scripts, or maybe the
Yes,
ancient
yes.
scripts, and then how we are extracting how we are getting the things, or how many languages are there, if you are into it, if you want to research about it, right?
Yes, 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 ma'am. Yes, ma'am. Yes, sure. Actually, while talking about scrapping out data from different data sources, the
Hmm.
focus of global context is different and Indian context is different. Now, because I'm talking about climate change and because I am an Indian, I will focus only on Indian climate change. So, for
Mm-hmm.
Indian climate change too, as you said, around 700 and more than 700 languages are present over here. So initial stage, I can take out only few of the languages as my prototype, input to my prototype, and work on that. But yes, sure, this is that's what I said. It is the crucial thing is to design multimodal or multilingual transformer or the multimodal model, multilingual model, because in that case I have to talk about all available languages in India. So as you
No,
said, this
yeah,
is
yeah. I was just like saying that 750 were there, but now at present we are only using between 100 and 200, not more than that. And if we talk about the social media, we are only using maybe
few of
20,
them.
25
Yes,
languages or 30
yes, yes,
languages.
yes,
Yeah,
yes,
so you will have some scope in that only you
yes, yes,
have to
ma'am.
work for only those many languages which are available, those on the social media only. But I
Yes,
just
ma'am.
told you that, I mean, I have worked on that as well. So that's why I just
Yes,
told you. Anyways, good work.
yes,
Thank you. Yeah.
thank you for the suggestion, ma'am. Thank you so much.
Yeah.
I'll consider this aspect too.
Yeah.
Okay, thank you, ma'am.
Thank you, ma'am. We'll be proceeding on with the next paper
Sorry.
presenter. I'd
Yes.
like to call upon paper presenter Pradnev B. Mahajan with the paper titled AIoT Enhanced Autonomous Mobile Robot for Smart Garbage Collection using YOLO V5 and YOLO V8. Ma'am, if you're ready, then you may start with the presentation.
Okay, sure.
Yeah.
Is my screen is visible? Hello. Is my screen is visible? Hello.
Yes,
Yes,
ma'am.
ma'am, it is visible.
Okay, fine.
Yes, ma'am,
Um,
it is visible.
okay. So my title of the paper is AI IoT Enhanced Autonomous Mobile Robot for a Smart Garbage Collection using a YOLO version 5 and the YOLO version 10. My name is Pradnya Mahajan. I am a research scholar at the Department of Computer Science and Engineering at JJU University, Rajasthan, under the guidance of Dr. Vinod Mureshwar Vaze, professor at the Department of Computer Science and Engineering at JJU University, and the Dr. Dattatreya Takle, assistant professor at the Vishwakarma Institute of Technology, Pune. Okay, so now in our cities are growing faster than our ability to keep them clean. The World Bank is predicting a massive jump to the 3.4 billions of tons of waste by 2050. But here, uh, the real issue. Our current way of handling the trash is stuck into the past. We will still sending a big trucks and fix the routes, whether the bins are full or not, which is the huge waste of the fuel and the time. So now we might think about the what about those smart bins and the sensors? So they are a start, but they have a blind spot problem. So here they only know about what inside them. So they can't see the litter on the side walks. They can't tell a plastic bottle from banana pill. And at the end of the day, they still need a human to show up all and do heavy liftings. So we realizes there are missing link in a system and that doesn't watch the trash, but actually goes out the and deal with it. So our solution to build something much more proactive as a AI IoT enhanced autonomous robot. So we just didn't want to just see, we want to understand to it. For that, we used a two-step brain. First, we use the YOLO version 5 to scan the area, and that thinks of this as a robot peripheral vision to find out the bags and the bins. And then we bring a YOLO version 8 for the detailed work, like identifying the specific material for recycling and all. But here, a robot can't survive on the camera alone into this busy city. So we gave in a full suit of sensors like ultrasound and proximity sensors, so it can dodge the obstacles in the real time. So all heavy thinking happens right there on the robot onboard computer. So, but here. It's also talking to the cloud. So this means the municipal team give it a live map of where the waste is and help them to manage the whole city much more efficiently. So actually, does it work? So yes, it is works. When we put our AI model head to head YOLO version it heads to the 97.2% of accuracy rate. So that's a big deal because the garbage isn't always pretty or easy to spot. So it's often crushed, dirty, or half hidden. So in our real world plot test, the robot completed its mission about 92% of the time, but the number of I am must say that is a 89%. That's how the often it successfully spotted the litter with that was outside the bin. So that's something so stationary sensors can do. So ultimately, what we are proposing is just it's just not a fancy gadget, but it's a shift in how we think about the smart cities, and we are moving from passive monitoring to the autonomous system, and that keeps our street clean and reduce the fuel waste and takes the hazardous out of waste management. So the primary contribution of our study is to a novel AI IoT integration autonomous robotic architecture for real-time urban waste detection, classification, and collection. Then the hierarchical deep learning detection pipelining leverages the yellow version 5 and the yellow version 8 for multi-level waste categorization with a superior accuracy and the efficiency, and complete experimental validations over the datasets, benchmarking, and the real-field robotic trials indicating the system priority over the existing IoT only waste management solution. Now here it is the literature review and a summary of the survey papers which I have taken in a year 2018 to 2025. So it is the study compared based on the years, system name, AI model which is used, and the waste type which is detected, performance, robotic capabilities, and the limitations. So first of all, there's Zeman and others in a 2024, they proposed a system called Shifty using a yellow version 5. It detects the metal, plastic, and polythene waste, and accuracy is around 81%. Robot uses a 6 degree of freedom robotic arm. However, here it supports the limited waste categories and does not use a newer model like YOLO version 8 or AI IoT integration. Then on and other. In a 2025, they developed the RoboSort using a YOLO version 8N and the YOLO version 8X. So it can classify the recyclable, biodegradable, and non-biodegradable waste. And the system shows the high performance with a precision up to the 96% and recall of 94.1%. So it supports the autonomous waste segregation and maintain the and the main limitations of is a lack of infrastructure integration and limited real world testings. Then the next is Chided that and others are in a 2025 they introduce a holonomic robot using a yellow version 5 and it detects the bottles, leaves, metals and the papers. The system achieves the 100% classification accuracy and 80 to 90% placement accuracy. So here the robot uses a holonomic wheels for the better movement, and however it faces gripping issues and it does not include the AI IoT features. Again, the next is Durga Devi and others. In a 2024, they worked on the plastic collecting robot using a YOLO version 8. It focuses only on the plastic waste. The system shows the higher efficiency and autonomous navigation, but it limited to plastic waste and does not support any AI IoT integration. Again, the SG and others. So they in a 2023, they proposed the Swachh Surveillance D robot. So it uses a deep neural network instead of YOLO. It detects the general garbage with up to 95% accuracy, and the robot supports the autonomous movement with a robotic arm. The limitations includes the limited waste type and no use of yellow models or the AI IoT. So overall, we can say that the most existing system shows the good accuracy and the automation. However, there are many other systems, they uses an older AI model, they detect the limited waste categorization. Also, they lack into the AI IoT integration for a real-time monitoring and the smart decision making. So this particular research gap motivates our research propose AI IoT enhance autonomous garbage collection system. So here it is, my proposed work. So basically, this is the block diagram of my waste detection and the classification. So here it is basically this using a smart cameras, smart bin sensors, environmental sensors, GPS location devices, and robotic sensors. I'm going to collect the data and data collection through AI IoT devices we have collected. Then the image processing and annotation on that will be done. So you using the normalization, normal noise removal, resizing, and labeling apply over there. Then the garbage image corpus construction over there. Then the after that, the collection, filterization, organization, annotation, and integration will be applied inside it. After that, the yellow version 5 stage. So here it is the full bin, trash bag, scattered waste, wet waste classification will be done. Then after yellow version 8, that basically it is used for the fine grain classification. So inside it, the plastic, metals, papers, organic, and recyclables are applicable. And the last one is the performance evaluation, like with a matrix like MAP, then precision, recall, F1, and FPS. So this particular proposed work contains these major 5 steps. So first is the data collection through heterogeneous AI IoT devices. So in this state, we collect the real world data from the different locations, such as the street, then public bins, then dumping areas and others. So data is collected under the different environmental conditions like day, night, rain, and very light. So we use heterogeneous AIoT devices like smart cameras, bin level sensors like ultrasonic IR weight and gas sensors, GPS modules for the locations, and environmental sensors for temperature and humidity. All this information is captured over the system of forming spatiotemporal data sets. All the collected data includes the waste images, sensor reading, GPS coordinates, environmental conditions, and these different data types are fused together to create a multimodal feature representation. So this steps ensures that the dataset closely represents real urban waste scenarios, which is basically essential for the accurate detection and the classification. The next step is nothing but the image pre-processing. So here the raw images are collected from the cameras and may contain some kind of a noises, light issues, or size variations. So pre-processing is
Excuse me, ma'am.
performed. Yes, ma'am.
I'm really sorry, but I'd like to remind you of the time limit.
Okay,
Yeah.
fine. So in this, the image pre-processing is done. Then the next is the data construction, data set construction. So in this, basically it is divided into the training data set, validation data set, and the test data set. Now, after that, the YOLO version 5, here it is the primary detection will be done. So inside that, the it classify into the full garbage bins, trash bags, scattered waste, wet waste containers, and all. Then this next stage is that is the yellow version 8, that fine grained classification. So here it is the basically focuses on the final output, that object location, which what is the object location, primary waste category is what, then fine grained material type is what, and then fused confidence code is what. So here it is my work. So now here it is the YOLO version 5 architecture. So basically it is divided into the backbone, make, and the head. Now, the for this particular proposed system, it is the experimental setup. So the device, the hardware edge which I have used, and other things. So basic evaluation parameters. I have considered the basic things that precision and I'm going to calculate the precision recall. So here the two true positive values, basically it for your for the waste object corrected detected, false positive for the incorrect detection where no actual waste exists, false negative that miss the waste object, and precision basically for accurate the detections recall. Then F1 score, then again the average precision, mean average precision, and here it is the result analysis. So here we can see the results are clear. While YOLO version, it is the grid model on its own. Our combined pipeline push accuracy to 98.1%. So but here is the real win isn't just that it sees the better. So it's that to understand the better. So our F1 scores is around 0.96. So that tells us the robot has found the perfect balance between being fast and being precise. So most importantly, our system's ability to perfectly outline an object, what we call the spatial awareness, jumped into over around the 82%. So this proves our hypothesis by using YOLO version 5 and to find the trash, and YOLO version 8 to identify it. So we have created a system that is more robust and reliable than any single model approach currently used into the smart cities today. So the conclusion, so what does all of this actually mean for the future of our cities? So essentially, we have moved the past old dumb trash bins that just sit there and wait. So we have built a proactive system that actually goes out and find the problem by using our Scout and Specialist AI approach. So we reach around 98% of accuracy, which is massive leap over the single model system that people are using today. And but the number I want you to remember, that is a 31%. So that is the reduction in mist trash. So that represents a cleaner path, safer sidewalks, and the less work for the human crews. So the future enhancements. So looking ahead, with we aren't stopping with just one robot. We are working on the multi-robot coordination, basically a team of this machines talking to each other through the cloud to clean a whole neighborhood in record time. And we build a scalable, high-tech solution to one of the oldest problem in the history, keeping our home clean. These are some references which I have used for this particular paper. Thank you. Is there any questions?
Yeah, nice presentation.
Thank you.
Yeah, I want to ask whether you compared your work with the state-of-the-art approaches, because you compare that with the YOLO's versions, right?
Yes, yes.
But
I
still,
have
it is
compared with the Yellow's version because I have stated this particular presentation regarding the Yellow version 5 and the Yellow version 8.
okay. But it would be fruitful that if you in the future you compare your work with the state-of-the-art works, because if you like
Okay.
taking the references, then
Mm-hmm.
that comparison is also required, you know. So that is
Okay.
important. Secondly, I
Okay.
also want to ask one thing, like you can come to that slide in which you mentioned the table, the existing works are there, and then you compare the things.
This
And
is
then in the third one, I mean, this third one is a journal paper or a conference paper?
it's a journal paper.
It's a journal paper. Okay.
Huh.
Generally, whenever we do the research, 100% classification is not achieved, and this is the best policy to carry out the work. So, I mean,
Mm-hmm.
I was checking that this publication is getting, I mean, this work is getting 100% classification. If we get the classification, I mean, you can please
But
cross check
there
and
is a issue inside the placement part. They
okay,
give the classification 100%, but the placement issue is there. It is about to 80 to 90% accuracy while
okay,
placement. Ah,
okay, okay. Thank you.
okay.
Thank you, ma'am. I'd like to proceed with our next paper presenter. We have with us Adra Air Nair with the paper titled An Overview of Static Random Access Memory-Based Compute and Memory Circuits. Ma'am, if you're ready, then you may start with the presentation.
Uh, Hello, ma'am. Am I audible?
Yes, sir, you're audible.
So, ma'am, there is some change. Like, we
Okay.
actually our paper person was Ardhara Nair, but she got suddenly scheduled an interview at Bangalore. So,
Okay,
I
sir.
am taking her place. We already sent you a mail about that.
Yeah, sir, there's no issue. You can start with the presentation.
Okay, ma'am. Thank you.
Yeah.
Ma'am, is my screen visible?
Yes, sir, it is visible.
Okay. So yeah, first I will start with by introducing myself. So myself Advaidal, I'm an fourth year electronics and communication engineering student from the School of Engineering. So this is our group paper. So our group paper is based on an overview for a random access memory based computing memory circuits. So first of all, I start with my introduction. So our random access memory is used to store data like there are commonly RAM are of two types, that is DRAM and SRAM. So what difference between DRAM and SRAM is like DRAM uses capacitors and they need continuous refreshing. So it actually causes their time delay and also not more faster than SRAM since they need constant refreshing. So mainly most nowadays conventional architectures basically use SRAM because they are a lot more faster because they use transistor and they does not require refreshing. So coming to SRAM, there are here we are introducing different types of SRAM. So we have done literature study on based on four SRAMs, 60, 14D, 10D, and 80. So at the end, we have studied all this and we have created our proposed idea based on, and about that I will speak at the end. So we have also introduced dummy cells here for our proposed work. So our goal is to achieve a small, flexible, power efficient electronic SIM design. So speaking about computing memory, first I will tell about what is the need for computing memory here. So modern application like in AI, machine learning, all these kind of things, data processing is one of the important content. So in normal processing data, the CPU needs to fetch data from the memory, then process it, then again need to send back to that memory. So it takes a lot of time for this processing. So it will increases time delay, and also the power consumption for the data transfer is also more. So that's why we are considering computing memory nowadays. What this computing memory means? The computation as well as the storage is done in the same memory array. So there is no need of unnecessary data transfer from CPU to memory, then memory to CPU. So that is why computing memory is essential here. So here we are trying to use SRAM based SIM. Why we are not trying DRAM? Is like, since DRAM is lot much slower than SRAM and it does not need refreshing, we are considering SRAM because they are much high speed and compatible. So and it is also highly energy efficient and high performance. And yeah, so first is our overview of our SRAM. So SRAM is computing memory. So here we can see two diagrams. So the left side block diagram is a basic SRAM cell. So a basic SRAM cell is 60, which means it uses 6 transistor. It consists of 6 transistor only for storage, and also processing is also done in here. But there are some issues within itself, like even though computation as well as storage is done in the same memory, there will be errors in data transfer since there are read and write path here. So since uh, read and write as well as computation is all are same for the same transistor, there will be some mix up with the data set. So that's why we are not basically using 60, because there are many disadvantages, and we can occur the many errors in data, because errors like during this switching in bit lines. So bit line is the path where these data are stored. So you can read on the right side, there is a diagram. There we can see on the left part BL, which means bit line. So these data can be this read and write data is carried through bit lines, and that WL means word line. It will decide which memory should be activated for the processing, and that M1, M2, and M3, M4 are the access transistors as well as storage transistors. So, speaking of the continuation of that, so as I said, it offers high capability as well as robustness, but still there we can bring more changes to it. So we can add more like more transistors. So for computation itself, so that we can arrange separate read and write path. So not only we can use same transistor for storage as well as computation, we have separate transistor for storage as well as computation, so that there won't be a mix-up in data structures. So after adding more transistors, we will get 10T as well as 14T SRAM. We will speak about both of them later. So yeah, that's the basic SRAM SIM design you have shown, you have seen before. And here we can see a low power 10T SRAM. So this is a low power 10T SRAM architecture. So we can see a bit SRAM array, like we have seen here in this block diagram. There are many 10T cells, and there are decoder, there are bit lines, and all these kind of things. So what we have done here is like we have added four more resistors, four more transistors to the basic SRAM, so that there are six SRAMs, six transistors for basic storage purposes, and as well as four transistors separate for computation as well. So what is the like advantage of this is like we have separate read and write path for our data. So we don't need to use same transistors for storage as well, which was the main issue in the 60. So actually, based on power consumption and energy efficient, 10D is comparatively very high when compared to 60. And yeah, so as far it says the architecture supports institute logic operations. As I said before, institute means like computation as well as storage is done in the same area. So this architecture supports that kind of logical operations. And yeah, the main attempt is for energy efficiency, even though it accumulates more area than 60, since we are adding more 4 transistor again, it won't be that area getting like it won't take that much space, but still it maintains a stable and robust computation process. And yeah, more than that, it is much faster than 60 since and much error free since it has separate read and write path, which is a main important part here. So it also provide parallel computation as well. As I said before, there are word lines which will enable only the necessary memories that need to be activated for the computation. So this is that's why we are using 10D for our proposed architecture. As I will tell that later. So yeah, as I said before, they are power efficiency and their area overhead. Even though they are accumulating more area than 60, they are maintaining a balance there between computation as well as stability. So speaking about our design with self-recoverability. So as I said before, we are introducing a proposed work using 10D SRAM. So in our proposed work, it can also self-recoverable. So normal SRAM, okay, in normal SRAM, while computation, the data is passed through bit lines. Okay, so if the necessary memory cell need to be activated, the data will be switched from each bit line. So during switching, there will be a power discharge, which is called a dynamic power. So since dynamic power is directly proportional voltage, there will be some voltage fluctuations. And due to this fluctuation, there can also causes radiation noises as well. So these soft errors will be affecting the data. Since it is stored in bitwise, if the data bit is 1, due to error, noise or radiation, it might changes to 0. So in our proposed work, our SRAM cell can correct that error itself during computation without any affecting the our performance. Like the computation will be done fast enough since there are separate transistor for performing that. And while during computation, if there is any error, of course, there won't be any block or any performance issue in our computation, since it will be self-recovered by our SRAM itself without affecting any of the computation profits or without affecting any of the speed of the performance. And how we are doing that is by like we are adding feedback transistors inside the bit cell itself. So feedback transistors, like feedback transistor is inside placed inside the 10T SRAM itself. So when soft errors occurs due to noise, radiation, and all, these feedback transistors, their job is to resolve these issues, while the other remaining transistors will continue doing their computation. So there won't be any performance issue, or there won't be any reducing speed or stability in the computation. So speaking about that, as we said, we have maintained self-recoverability in our proposed architecture. Also, we are trying to protect or shield our SRAM bit cells using dummy cells. So you can ask, what is dummy cells? So dummy cells are non-functional SRAM cells. Okay. So their functionality is they are just bit cell, SRAM bit cell, but they are non-functional. So what we are doing is we are placing these dummy cells around our bit cells, which are performing our computation. And when due to fluctuations, you can see noise is coming from both sides. So when due to fluctuation and other things, when noise or radiation comes, the dummy cell take the first hit. So actually the most of the errors will be absorbed by the dummy cell. Okay, so only soft error will affect our original bit cell. And for that also we have solution, because as I have previously mentioned, we have feedback transistor inside the bit cell itself to solve these kind of soft errors. So main errors will be absorbed by our dummy cell. That is the main functionality of our proposed work. So we are covering dummy cell around all of our bit cells, and these absorb our noise and suppress charge that will toggle our data. So yeah, that these two components are the main part of our project. And speaking on next is, as I have said before, there are since SRAM basic SRAM is a 60, it don't have
Excuse me,
separate
sir.
read or write path. So we
I'm
are
really sorry
okay.
to interrupt you, but I'd like to remind you of the time limit.
Yeah.
Yeah.
Okay, so as we have mentioned about 10T here, 14T uses 8 additional transistors. Since it is using 8 additional transistors, it is accumulating more area. It is accumulating more area for that, and the design complexity is much more difficult than 10T. That's why we suggested to use 10T instead of 14T for our proposed work. Since 10T has the same specialty like 14T, it has separate read and write path, and it has improved static noise margin. Like it will indicate us how much our data can be computed without any affecting the error. So it will show us that. But since 14T is not suitable for actually high computation, it is always preferred for slower devices, because it causes higher power consumption in high devices. In case of slower devices, it will be done computation will be done very fast, and power consumption will be very less. So in case of normal conventional architecture, our 10T is more suitable to perform computation. That's why we initiated to take 10T for our proposed work. So these are comparison between doing our literature study. This is our comparison between 60, 80, 90, and 20, 40D. As you have seen, energy efficiency is very high for 10T, as well as read and write stability is very high for 20. Even though these 40 have same as very high and error tolerance also very high, but due to adaptive logic and for area efficiency, we are performing 10T, and as I said before, for better power consumption, 10T is much preferred than 14T. So, so now moving on our proposed work. So when I'm saying about computation, basically it is on we are doing AND, XOR, and XOR. These all kind of computation are done in normal SRAM. But during in normal SRAM like 60 and 14T, all of these operations are done even though they are unwanted. Okay, so there will be unwanted switching between bit lines. We don't need to do that computation itself, but these SRAM cells are doing all that, even though we don't want that kind of logical application. So in here, what we are doing is we are designing an error-tolerant computing memory using conditional logic and dummy cell shielding. As I have mentioned about dummy cell shielding, I will speak about conditional logic. What do you mean by conditional logic? Is like we will perform XNOR and XOR. These are main three computational process, and only the required logic will be activated through the word lines, so that there won't be any unwanted bit line switching between bit lines, and also this can reduce maximum number of errors during computation. So that is one of the main achievement of this of our proposed work. So as I said before, we have self-recoverability, which is for that we are using feedback transistor in our SRAM cells. And as you can see here, this is our block diagram of our proposed work. We have covered dummy cell between bit lines, and this is our 10T cell. So this dummy cell will actually absorb most of the errors from the switching of bit lengths, which will be in the form of noise, radiation, charge discharge, all kind of things. So these will be absorbed by dummy cells, and after that, even after absorbing all of those, there will be soft error that will be reaching the 10T cell. So that will be absorbed by the feedback transistor in our bit cell, and we are performing conditional logic so that only the required memory will be accessed and required logic will be accessed, so that we can avoid unwanted bit changing, and thereby reducing maximum number of errors, and we can increase the error tolerance of our device. So yeah, these are some of the benefits we are studied and mentioned here. So actually error rate is increasing due to shielding activities also. So here we can mainly reduce these errors by using shield active cells, which will be more in comparative with other bit RAM cells, since there is no feedback mechanism for normal bit RAM cells. And yeah, by maintaining balance and not much area, we can increase the robustness as well as reliability itself. So data movements and time delay can be reduced by since we are using SIM itself. And yeah, rest of the points I have already mentioned. It is energy efficient and has fault tolerance. Even though it is affected by error, it can still maintain to perform computation without any affecting this computation. Yeah, so it is suitable for noise-prone environments. And finally, its application and its future scope. So, our proposed SRAM in SIM architecture can be suitable for many energy efficient AI and coming machine learning applications also. So, it is very suitable for edge computing systems as well, where low power consumption is used, since its area efficiency and transistor count is less, so that it accumulates only less power. And as I've said before, due to our self-recoverability and dummy cell shielding, our error tolerant self-recover design makes it suitable for noise sensitive. And yeah, we are trying on future work. There are many possibilities for future work, like multi-bit operation and that kind of things. And also we can increase more performance with and more stability with it. So yeah, that's all about our project. Thank you. So these are all the reference paper we have. I forgot about mentioning that these are the reference paper we took for our literature study, and we have taken 10 papers for our reference. And yeah, that's it.
Okay, good
Any questions?
presentation. Yeah. I want to ask, in your survey, which approach appears more suitable for edge-based AI applications?
Ma'am, for edge based, yeah, that was our main concern. Like, can suit out for edge place? Like, we have compared it with 14T, and we have compared it with the 10T, because that was the two extra we have come finalist with. And based on the, as I said, since 14T is too much design complexity, and as well as it takes higher power consumption. Mainly, we are suggesting 10T is better, since it is a balanced design and it is more suitable for its computation than 14T extra.
Okay, thank you.
Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to call upon paper presenter Madhusmita Chakrabarti with a paper titled Automated ECG-Based Diagnosis of Cardiac Disorders Using an Effective Deep Learning Model. Ma'am, if you're ready, then you may start with the presentation. Ma'am Madhusmita?
Yeah, I'm trying to share the screen. Please
Sure, ma'am. Please
let
go
me
ahead.
know. Please let me know if it is
Yes, ma'am, it
visible.
is visible.
Thank you. Okay, good afternoon, everyone. My name is Madhusmita Chakraborty, and I am from the Department of Electronics and Communication Engineering at Tezpur University. So today, I'll be presenting our work on automated ECG-based diagnosis of cardiac disorders using an effective deep learning model. This work is a collaborative effort with my colleagues Navapratim Das, Deepika Hajarika, and Navojwal Acharya and Professor Vijay Kumar Nath. So cardiovascular diseases are the leading cause of death worldwide, causing over 18 million deaths annually. Heart rate and rhythm are critical indicators of cardiac health. Deviations from normal can indicate arrhythmia or congestive heart failures, that is CHF. Arrhythmias can be life-threatening, and CHF occurs when the heart cannot pump sufficient blood. The ECG, composed of P waves, QRS complexes, and T waves, is the gold standard for diagnosis. However, traditional ECG interpretation is time-consuming and subjective depending on expert cardiologists. So in this study, we have tried to automate the ECG classification process using an effective deep learning model, which is both lightweight and efficient. So automated ECG-based diagnosis has gained attention due to the limitations of manual interpretation. Some existing methods often transform 1D ECG signals into 2D representations or use hybrid models combining CNNs and recurrent networks. While effective, these approaches are computationally expensive, sensitive to hyperparameters, and sometimes fail to capture both local and global features of the ECG sequence. So to address these issues, we designed a one-dimensional convolutional bottleneck module using a compressed process expand strategy with skip connections for accurate classification of arrhythmias and cardiac conditions. So for this study, we have used two datasets. Dataset 1 consists of 5 AMI standard classes. So AMI stands for the Association for the Advancement of Medical Instrumentation. Here we have used 5 standardized classes. Here N stands for normal beat, S stands for supraventricular beat, V stands for ventricular beat, F for fusion beat, and Q for unclassified beat. And in this dataset, it consists of 48 segments of 2-channel ECG. These are collected from 47 subjects at both Beth Israel Hospital. And the second dataset, it combines 3 datasets. It combines MIT-BH arrhythmia, BIT-MC CHF dataset, and MIT-BH NSR dataset. Here, NSR stands for normal sinus rhythm. Again, here IARR stands for arrhythmia, and CHF stands for congestive heart failure. So in the two tables in dataset 1 samples, we can see that the train set contains 4,31,100 samples, and the test set it consists of 1,07,775 samples, and a total of 5,338,875 samples. Dataset 2 contains 6,480 samples in the train set. In test set, it contains 1,620 samples and a total of 8,100 samples. This is the complete workflow of our proposed method to detect and classify cardiovascular disorders. So our proposed framework, it takes ECG raw data as input, and then the data is pre-processed, and then we have splitted the data into 80% 20% split, and then the train data is fed to the classification model, and the model is trained. And after the model training, we have evaluated the performance of the model using the test data, 20% test data. And finally, the model will classify the various CVD conditions. So we have the ECG data is pre-processed using XQRS algorithm. This XQRS algorithm consists of mainly three steps. So first step consists of high frequency noise removal using a low pass filter with a cutoff frequency of 50 Hertz and a sampling rate of 360 Hertz. Then we have done baseline wonder elimination via linear detrending. And then we have normalized the signal to zero mean and unit variance. For the dataset 2, we have resampled the ECG signals to a common frequency of 128 Hz. Then we have done baseline drift removal using a fourth order Butterworth high pass filter with a cutoff of 0.5 Hz, and power line interference suppression using 60 Hz notch filter. So figure 2, it shows the raw and denoised ECG signals from MIT BH dataset, from BID MCCHF dataset, and MIT BH NSR datasets. Figure 3, it shows our proposed ResNet inspired 1D CNN framework for ECG based CVD classification. So we can see that this framework, this network is mainly consists of 1D convolutional layers and the bottleneck layers, and one max pooling layer and one global average pooling layer, and the final probability classification is done with softmax. So the process signal is first fed to the convolutional 1D layer, and then it is maxfold, which is followed by one block of convolutional layers, and there is one skip connection to help the gradient flow, and then it is followed by one bottleneck layer. The bottleneck is explained in this figure 4. The bottleneck block design here uses 1D convolutional layers and Bayes normalization layers and some ReLU activations, and one skip connection to help the gradient flow. So our proposed model is evaluated using 2 datasets, and the model training was done on PyTorch framework, and Adam optimizer is used with a learning rate of 0.001 with a batch size of 32, and it was trained for 80 epochs. Figure 5 shows us the confusion matrix after the evaluation of the proposed CNN model. We have tested the model using our test data for dataset 1. We can see that as our dataset had 5 number of classes, so we can see from the confusion matrix that the class 1 for class 1 776 number of samples were correctly classified, while 7 number of samples were incorrectly classified, and for class 1 89,610 samples were correctly classified, while 3 samples were incorrectly classified. For the class 2, 8,000 samples were correctly classified, while no sample was incorrectly classified. Again for the class 3, for class 3, 2,835 samples were correctly classified. For class 4, 6,535 samples were correctly classified. So table 2, it shows the performance evaluation of the proposed framework on dataset 1. So we can see that from the table the per class accuracy, sensitivity, specificity, precision, and F1 score for each class, and with an average accuracy of 99.99%, with an average sensitivity of 99.76%, with a specificity of 99.98%, with precision of 99.95%, and F1 score of 99.86%. For dataset 2, we have used 5-fold cross validation. So For each fold, we can see the confusion matrices for the proposed framework on dataset 2. We can see for fold A, for fold 1, we can see that for class 1, 359 samples were correctly classified. For class 1, for class 0, 359 samples were correctly classified. For class 1, 960 samples were correctly classified, and for class 2, 299 samples were correctly classified, and so on. Here, table 3 shows the performance evaluation of the proposed framework on dataset 2. We can see that fold 3 gives the best results. It shows 99.96% of accuracy and 99.97% of sensitivity, 99.97% of specificity, 99.89% of precision, and 99.93% of F1 score, with an average of 99.86% accuracy, 99.80% sensitivity, 99.88% specificity, 99.73% of precision, and 99.76% of F1 score. So we have compared our results with the state of the art existing works. So we can see from the table 4 that our proposed model has shown extraordinary results with accuracy percentage of 99.99, with sensitivity of 99.76%, with specificity of 99.98%, with precision of 99.95%, and with F1 score of 99.86%. This table 5 shows the comparison of our proposed of the results of our proposed framework with the existing methods for dataset 2. So we can see that for dataset 2 also, our proposed framework has achieved the best results compared to the existing works on this field. And our proposed method has achieved 99.86% and sensitivity of 99.80%, a specificity of 99.88%, precision of 99.73%, and F1 score of 99.76%. So to conclude, we have designed a robust and lightweight deep learning framework, and it was very much effective for automated ECG based cardiac disorder diagnosis. And the framework was a ResNet inspired 1D CNN with a novel compressed process expand bottleneck, which effectively captures local temporal ECG features. It was evaluated on ECG datasets including MITBH arrhythmia, and a combinational dataset consisting of both the 3 datasets, that is MITBH arrhythmia, BID-MC congestive heart failure dataset, and MITBH normal sinus rhythm dataset. The proposed framework has achieved 99.99% accuracy for AMI-based arrhythmia classification, and for the dataset 2, for the combinational dataset, it has achieved with an accuracy of 99.86%. Thank you. These are the references I have used in this paper. Thank you.
Yeah, good presentation.
Thank you, ma'am.
Yeah, I want to ask, how does the model capture both temporal and morphological characteristics of ECG signals?
Ma'am, as we have seen in the model itself, the convolutional, it is a combination of both the convolutional layers and the bottleneck layers. The convolutional layers extract the temporal features,
Okay.
And yes, and as the ECG signals are some one-dimensional features, so we have used 1D convolutional layers here.
Okay, thank you.
Thank you, ma'am.
Thank you, ma'am. I'll be proceeding with the next paper presenter. I'd like to call upon paper presenter Goldie Priyadarshini with the paper title Deep Learning Techniques for Dermatological Disease Classification. Ma'am, if you're ready, then you may start with the presentation.
Yes, ma'am.
Yeah.
Ma'am, may I audible?
Yes, ma'am, you're audible.
Ma'am, my screen is visible?
Yes, ma'am, it is visible.
Okay, ma'am. Good afternoon, everyone. I am Goldie Priyadarshini. Today, I am going to present our project titled Deep Learning Techniques for Dermatological Disease Classification. So, first of all, I'm starting my introduction part. Skin is the largest organ in our body. Skin diseases are very common and affect people of all ages. Some skin problems are minor, but others, like skin cancers, can be very serious if not detected early. The main problem with skin disease diagnosis is that many diseases look very similar. Diagnosis depends on expert dermatologists. Manual diagnosis is time consuming and can sometimes lead to errors. In many places, especially rural areas, dermatologists are not easily available. So now the question is, can technology help doctors in diagnosing skin diseases faster and more accurately? This is where deep learning comes into picture. So the objective of the project is to develop an automatic skin disease classification system using deep learning. The proposed model is entered into assist dermatologists by providing fast, consistent, and reliable predictions, especially in teledermatology and resource limited healthcare settings. So, our goals are to classify 10 different skin diseases using dermoscopic images, to use transfer learning with the ResNet 18 model to improve accuracy with limited medical data, and to assist doctors in early disease detection. The system is designed to support dermatologists, not replace them. So, the related work is earlier the skin disease detection was doing using traditional image processing methods, machine learning algorithms like SBM and random forest. These methods required manual feature extraction and did not perform well for different types of skin lesions. Later, deep learning models like CNNs showed better performance because they automatically learn features from images. Pre-trained models such as ResNet 18 helped improve accuracy, especially when medical data is limited. So, the dataset and materials is for our project, we used skin images from ISIC archive. The dataset includes from HAM 10,000. Here we include more than 26,000 of skin images, 10 skin disease categories such as eczema, melanoma, psoriasis, warts, and others. The images have different lighting conditions, skin tones, and lesion types, which makes the dataset more realistic. So the methodology we use ResNet 18, which is Deep Convolutional Neural Network or CNN. Instead of training the model from scratch, we applied transfer learning. The model was already trained on ImageNet. Early layers detect basic features like edges and colors. Final layers we are trained to identify different skin diseases. We replaced the final layer of ResNet 18 with a new layer of 10 disease classes. This approach reduces training time, improves performance, works well with limited data. So the result and discussion is the of this model is the experiments were um, the experiment were done using MATLAB software, and to improve accuracy, we use data augmentation such as image rotation, flipping, zooming. The data set is split into 80% of training and 20% of testing data. All the images were resized to 224 into 224 pixels and normalized to match ImageNet standards. And the Adam optimizer was used with a mini batch size of 32 and optimized learning rates for stable convergence. Training and validation accuracy showed steady improvement while loss value consistently decreased. The results show that the model correctly classifies most skin disease images. Some errors occurs when diseases look very similar. Overall, the performance is good and reliable. And despite these strengths, certain limitations remain. Misclassifications are mainly observed among disease classes with visually similar characteristics, highlighting the challenge of distinguishing between overlapping dermatological features using image data alone. In addition, the proposed system realizes exclusively dermoscopic images and does not incorporate complementary clinical information such as patient age, medical history, or lesion location, which could enhance diagnostic accuracy. Moreover, the class imbalance within the dataset may adversely affect prediction, confidence, and performance for underrepresented disease categories. So, the moving on that, the conclusion is to conclude, we successfully developed a deep learning based on skin disease classification system using ResNet 18. The model achieved an accuracy of 81.38%, showing that deep learning is effective for medical image classification. The system can be useful in early disease detection, teledermatology, assisting doctors in decision making. In the future, we can use more data, add patient clinical details, improve accuracy using advanced models, include explainable AI for better understanding. Thank you for listening patiently. I will be happy to answer your questions. Thank you, ma'am.
Okay, good presentation. I want to ask, how did you handle variations in lighting, skin tone, image resolution, and background noise?
Ma'am, by using segmentation, we did everything.
No, okay, segmentation is there, but still these features, I mean, these are important features. So how did you handle those features? Lighting, in case like skin tone is different, or you have some different image resolutions. So how did you handle that? What approaches or formulas, etc., you applied for the same?
Ma'am, the data set was contains very vast images, and so within
No, no,
that
no.
we
Already.
yes sir.
That madam is asking about how the skin tone is different, lighting condition is different. There may be some noise within the images. So then how you can handle? Madam, we are using actually a normalization. Initially, after the pre-processing, in the pre-processing stage, we are doing the normalization process.
Okay, and what about the class imbalance?
Class imbalance means that one is most probably different imbalance classes, but we mostly taken 2,500 from the randomly selected, actually. And for the data leakage, we are again using the TTA. You might have learned that TTA, test time accommodations.
Okay. Okay, thank you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am. I'd like to call upon our next paper presenter, Mathan S., with the paper title Deep Fuzzy CardioNet, a next generation risk prediction model combining social behavior data and clinical biomarkers. So if you're ready, then you may start with the presentation.
Yes, ma'am.
Yeah.
Good afternoon, everyone. This is Mathan, research scholar, Jaipur National University. I'm going to present this paper along with Sunil Gupta. My paper title is Deep Fuzzy CardioNet, a next generation risk prediction model combining social behavior data and clinical biomarkers. So these are the sessions we are going to see in this session: motivation, introduction, literature review, and result and comparison, conclusion, discussion, and limitation. Motivation. What motivated to do this paper? Mainly the CVD death is a major crisis all over the world. Cardiovascular disease causes 25% of all death in India. And another major crisis is the cardiologist gap. According to Indian Heart Health Association, there is only 4,000 cardiologists registered. But to overcome the population, there is 88,000 cardiologists required right now to serve the population. So main concern is there is not enough cardiologists to treat the growing number of patients. And also cardiologic CVT procedures are often always take long time and it will delay the treatment. It may cause a lot of lives in stake. So many people cannot access quick medical help also during emergency. So these are the things motivated to do this research, mainly cardiologist gap. We need to fill the cardiologist gap with some intelligent medical systems actually. So, and also India has like almost 13 million doctors actually. So there also the ratio is very less, like 1:811 doctors are registered right now, but it's required 1:2000 actually. So we need their intelligent system to at least predict some kind of disease, and it can refer to the cardiologist to just overcome the overload of the cardiologist. So introduction, cardiovascular disease is a leading cause of death globally and India, everywhere. So globally, it was almost 31% of all death, and it's in the top third death all over the world. So it's very important. Early detection of CVD is crucial and reduce death, and it can improve patient outcomes. There is a lot of diagnostic systems available, but still it faces a lot of challenges and limited accuracy and limited feature optimization. Sensitivity is very important in the clinical point of view. So lack of sensitivity also. So mainly it's nowadays cardiac interpretation is mainly clinical, subjective clinical interpretation is required because there is because it may lead to variable results. It will may lead to doctor to doctor. It will vary the results also. So this is a normal cardiac CVD diagnosis workflow. So normally patient will come with the symptoms, then clinical risk assessment, history, BP, ECG, and screening, everything, identify the risk individuals. Then they will do the laboratory testing and to detect some cardiac injury. Imaging is required to access the heart structure. So invasive test also is there, angiography to plan for the treatment. Nowadays, some ECG also coming with the AI. It's already available. It can predict and it can suggest that all the wave pattern, if there is any abnormality, it can able to suggest. So still we need to overcome. This main point is to overcome the cardiologist gap. That is because we cannot fill the gap of cardiologist within certain number of period because it's a huge amount of 98% of the gap is right now. So to solve that one, we need to have some intelligent system. It should work with a low resource healthcare facility also. So this is the general CVD diagnosis clinical workflow. The patient will come with the symptoms, then history taking, then physical examination, then vital signs, then they have to go for ECG acquisition, then blood test, X-ray, then cardiologist intervention is required to analyze all these results. Then he has to do some echo scan, cardiac MRI, stress test. It's all time intensive. And it's also observer variability because he has to put his subjective interpretation to identify. Maybe he has to do the diagnosis based on his experience. Then only he can able to create a treatment plan. It may create some manual error, and it will vary to doctor to doctor. So this is overall time consuming. And as we discussed, to reach a cardiologist, it's very difficult. It's not available everywhere. A lot of patients cannot reach cardiologist easily. So there is artificial intelligence and machine learning coming into place to do a lot of to design some smart system to identify CVD risk. Artificial intelligence can think and make decisions like humans, and machine learning is like part of learned data without explicit instruction. Medical data, it's mainly, we need to understand medical data is not, lot of data is wrongly labeled. We need lot of optimization in the data set itself. Because a EMR adoption ratio, if you compare in all over India, developed country and India, EMR adoption ratio is very less. That means clinical documentation is very less. And nowhere we can find that the clinical documentation is 100%, because high facility hospitals itself in the cities and at all, it's completed only 35% according to the EMR adoption ratio. So still need lot of improvement. Then road resource areas, there is all wrong label data you can expect. So we need to build a system to overcome all this kind of data. We need to generalize the data, generalize the vital signs and all kind of inputs, and we need to provide some good system. So we require some artificial intelligence or machine learning to do this process. So we are proposing deep fuzzy cardio net. It's a hybrid fuzzy and deep learning model using enhanced data set. Here we are just taking the patient data. So then we are doing the pre-processing with the data, because I said data pre-processing is required. Because what in this we are doing, like mainly we are taking two kind of features, because to identify the risk before cardiologist, when they reach with the symptoms, we need to have the social history and the basic vital signs. So we are trying to predict the risk based on social behaviors and clinical biomarkers. So social behavior in the sense like social activities, like what the physical activity the patient has, and what kind of diet he has, sleep patterns, and different type of social behaviors we are recording. So it can also make a lot of difference in the CVD prediction, because it's a smoking, his sleep pattern is not good or something like this. All these kind of parameters, social behaviors we are taking. And clinical biomarkers, something like basic clinical biomarkers like blood pressure and cholesterol, and kind of like diabetes or something like diabetes, and also different types of BPs, we can take it, and cholesterol, everything we can take it out. So these are the clinical biomarkers, and basic blood test we can do it to identify diabetes related issues. These are all, we are combining these two, social and clinical biomarkers, and we are combining these two and providing fuzzy logic to identify, because we have to use something kind of linguistic model, because we are taking the numerical values. It will come from the data, numerical values. We have to convert into linguistic, like normally we will say blood pressure is low, medium, or high. It should understand by the network, and it can be easily predictable, something like this we need to provide. So that's why we need to perform the linguistic model. So these are the literature review. We have reviewed some of the literatures. So it has some of the models like ECG and demographics it's using. Its accuracy is 91%, and some of the things like laboratory and clinical features using. Some of the studies is using social and clinical. Some studies it's only using diet and sleeps. So mainly what we are concentrating on social and clinical features, and we are bringing like lightweight model. It should adapt with the low healthcare settings also. It's like low infrastructured healthcare settings it should adopt. So scope of this one, social, because most of the existing models limited inclusion of social lifestyle factors. That is like immediately just that is important features. We need to have a social history of the patient, and uncertain data, because we are just doing the fuzzy logic to optimize the data here. So that is also we are handling in this paper. Lack of interpretability with advanced models. Many deep learning predictions operate black boxes, so decision difficult to clinicians to trust and understand the situation. So we are using some fuzzy-based shape visualization also we are using. It can help the clinicians to understand what parameters used to predict this risk factor. So we have used a data set like Enhance that there is 9,820 adults aged 18 plus CVD identified based on the report, diagnosed heart attack and angina and stroke kind of things. Both clinical and social factors we used here. So we identified the three values are cleaned and standardized, grouped into low, medium, high level using the fuzzy logic, and features resulting 32 key variables we used. So these are the data set description. We are, as I informed, like we are using BP and cholesterol and some of the diabetes related and social histories, lifestyle history, everything we are using, smoking status, alcohol, physical activity, sleeping duration, and stress index. So diet quality also. These are the proposed methodology. In this proposed methodology, so we are taking the data set like from Enhance and the collected data feed into the fuzzy rule-based feature optimization, because we have two different types of set of data available in that data set. So one kind of thing, social life history and the clinical biomarkers. As we said, clinical biomarkers has like all the clinical related vital signs, cardiac related vital signs. It can feed into the fuzzy
Excuse me, sir.
rule-based feature. Yes.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Sure.
Yeah.
So fuzzy processing layer, then it will convert as a linguistic term. Like I said, like it can be converted as a linguistic terms, low, medium, high, normal, abnormal, that kind of characters. Then it went into the deep neural network part. There is a multi-stream neural network we used. Okay, well, because we need to handle the social stream and clinical stream. So multi-stream will handle both of the social and clinical stream. So there is a ReLU network we formed. Then LSTM unit, it will handle, we have LSTM also, because it will handle the dropout layer. If there is uncertainty in the data, it can generalize the data and it can feed into the network. It can it will help the prediction, true positive values. It will increase the sensitivity of the patient. So attention mechanism, because it will identify the critical features, like some of the features, linguistic term, like which features we need to take it for the attention. Maybe some of the patient is smoking and his BP level is so high, then it can take it to the consideration. That kind of things, attention mechanism we use. Then CVD prediction, that network layer, it will do the CVD prediction. Then shape features, it will visualize SHAP, it will visualize, because shapely additive explanation, that is a powerful technique. It can explain, it will visually explain what kind of features used to predict actually. Then it will help the clinicians to understand or understand the authenticity of the results. So it will help them to do. So these are the proposed methodology. I already explained. The final rail produced the CVD risk prediction. The experimental setup, we used 70% of the training and 50% validation and 15% for testing. So we compared with this model with the general model. All the cardio mainly used linear regression, SVM, RF, and MLPC and an LSTM. We compared with the model. So these are the comparative results. See, we are achieving accuracy also 92%. Sensitivity is 88.5. So compared with all other model, which are all using like social and clinical factors. So clinical factors, then we are at least identifying like that our accuracy is so high and the sensitivity is also so high. So these are the results. The confusion matrix, we used like predictor patient 1278. And these are the ablation study, like we used study, we identified like with social, clinical, and fuzzy, without fuzzy processing. So almost our accuracy will be very high. And so this is the ablation study. And the discussion, we have like almost reached 92% of the accuracy, and the improved performance, social factors, activity, we can suggest like limitation. We have to use like a lot of cross-sectional data, like increase the data, like in the clinical factor also, we can increase social factor data also, we can increase. Conclusion, achieved 92.4% and accuracy is 89%, and it's a very lightweight model. We can adopt. It can, if we include with the clinical profiling, so it can detect the complete things while taking the vital sign itself. It can predict and it can suggest the doctor. It can be referred to the cardiologist or not. So scope of futures work, it can be like tested with the different other data sets, and also it can like wearable devices, they can able to have it. These are the reference I used in this paper. Thank you so much for providing this opportunity. Hello.
Yes, yeah, I've seen a good work. Just a minute. My question is, why was fuzzy logic chosen over purely probabilistic or attention-based fusion techniques?
Yeah, ma'am. Fuzzy logic is used to like to detect linguistic to convert to that normal value, the numerical value to linguistic, because linguistic like means like for example, we are converting values. For example, BP is some value because we need to provide. Then it will be the prediction level, risk prediction. I need to convert as a linguistic. It's like low, medium, high. Then it can like the attention mechanism. It can take, for example, the social behaviors is abnormal, then BP is abnormal. It can combine, it can easily choose that very important features, like critical features. That's why just converting fuzzy rule based to convert as a linguistic terms.
Okay.
That is the one. And then second phase, we are using shape function for the visualization fuzzy. That's it. Thank you.
Okay, my another question is, how scalable is a system when integrating continuous data from wearable or IoT devices?
That's why future work I just mentioned, because now what it will help, like when they take, like for example, vital signs from the system, it will automatically detect. Future works maybe same thing. Like when you enter vital signs and social history, immediately it will detect the risk prediction. So the same thing will automate. It will come from the wearable device. All the vital signs will come from the wearable devices. Then it will convert as a linguistic term. Then it can able to detect. Now, clinically also EMR, when they record, now normal software itself, it's automatically doing like a low or medium high based on the value. There is no fuzzy used, but it's directly, it's comparing. Maybe they have a normal limits like 120, BP is 120, means like it's a normal. Like this, they are predicting because there is no 125, something like this. There is no the percentage of normal or percentage of this one cannot predict it because directly they are predicting low, medium, high like this.
Okay, thank you.
Thank you. Thank you so much.
Thank you, sir. Thank you, ma'am. I'd like to move on with our next paper presenter. We have with us Kehna Sachdeva with the paper titled Enhanced Stock Price Prediction Using Machine Learning Techniques and Social Sentiment Analysis. Ma'am, if you're ready, then you may start with your presentation.
Yeah, sure, ma'am.
Yeah.
So my screen is visible.
Yes, ma'am, it is visible.
Thank you so much. Okay, so good afternoon, respected ma'am and all the participants. My name is Kehna Sachdeva from Harvard University, Rajkot. So today I'm here to present our research work. Title is Enhanced Stock Market Prediction Using Machine Learning Techniques and Social Sentiment Analysis. So this work is done jointly with the Amman Singh and the Ashutosh Kumar Gautam. So in this presentation, I will briefly explain the problem we are addressing, the approach we used to result we obtained. Okay, So we'll start from the introduction part. So as we all know, the stock market is one of the most unpredictable system. So stock price don't change because of just for the one factor. And we can say that they depend on the company performance, government policies, global events, and the event public emotions as well. So a very good real examples, if I say that COVID-19. So during that time, the market suddenly crashed and then recovered very fast. So many investors were confused because traditional predictions method failed to explain what was happening. So in that case, we this is where the machine learning become very useful. So machine learning model can study your past data, they can learn your patterns, and after that they adapt it. So when we have a new data comes in, so instead of guessing, the model learn from the real market behavior, which help to the preparing your models predictions. Okay, so if I talk about the problem of statements here, so problem of statement here, we can say that the stock market price prediction is a complex and the challenging task due to the highly volatile and non-linear and uncertain behavior of financial market. So traditionally, statistical and the regression based forecasting technique are unable to model to hidden the pattern present in the large scale time series stock data. So even existing machine learning model often suffer of the problems such we can say that overfitting your high variance and accuracies. So if I talk about the super vector machines which I use in this paper, so unstable performance for the long time forecastings. So there is a critical need for the robust and the reliable predictions to model that the minimize predictions error and the performance as well. So even today, predicting stock price accurately is still a big challenge. So traditionally, market methods follow fixed some rules and assumptions and formulas, so they cannot handle the sudden market changes. So some machine learning model are also not a perfect. They sometimes overfit and unstable result. They give you predict if you are using the longer duration. So the model of super vector regression work well in some cases. So, but there the performance drop when the market condition change. So the main problem is to build a model that is stable, who is stable, accurate, and reliable even when the market behave unpredictably. So next we go for the objectives. So as an objective, the main goal of our research paper is to improve the stock price prediction accuracy using the machine learning. So we wanted to study historical data properly and we extract the features and apply the more models. And another important objective was to compare our proposed approaches with the existing methods like a spot vector regression. So there that we can clearly show the whether our model is performance better or not better. So if I talk about the models here, so in our prediction model, we start over collecting the data, market data. So instead of the market data or the prices, we adjust the prices and open a high, low, or either close volumes, and this help to reduce the error of the sudden market changes here. So we also the calculate additionally features like percentage change and high low percentage here. So after this, all the data is prepared and divided into the training part and the testing part so that model can learn easily and evaluate properly. Okay, so next one is your methodology. So our methodology is based on the random forest regression approaches here with the least square optimizations. So what we do is in the first we smooth the historical data using we can say that they help to remove the noise and the sudden spikes here. Then we extract technical indicators from the data and multiple decision tree are trained using the different subset of the data set. So each of the trees make own predictions. So finally, all the predictions are combined to produce your final output as discussion tree. So it reduces the overfitting and improves all over the accuracy here. Here is a flow chart. We can say that workflow of the diagram. So this diagram show the complete flow of our system. So first we collect the historical stock data. After that, we pre-process the data to improve your noise, and we can say that find the missing value if have, how to handle. So it's a handling part. And after that, the important features is your extract. So the data is then split into the training part and the testing part from the data set. And the training data used to train to learn the model, and testing part means testing data, we can say that used to check that how well the model perform. And finally all the steps, so finally the predicted result are evaluating using the sum of the matrices, which I follow in this paper, and the steps is follow for the system required. And after that, if I talk about the data set, how I collect, so data set is, so our experiment is used to 10 year of stock market, which I say that 2006 to 2015. So we are focusing two major things, Sensex and Nifty here. So the data was collected from the officially NSE and BSE sources. So all the experiment were performed using some of the libraries, and we use here as a, we can say that 100 trees in our random forest model to ensure our learning, means ensure our prediction part. So after that, you can have a conclusion, means the conclusion of the paper is, in that case, to evaluate the models, here we use some of the matrices like as a MAE, RMSE, and MSE to compare the purpose model using the sport vector regressions. And from the result, we observed some models that give the lower error values, and especially for the multi-days predictions. So to the conclude, our study shows the machine learning significantly improve stock price prediction, and the least scare random forest model handle market better and the more reliable predictions here. So it performed better than the traditional model. For example, I said it key sport vector regressions here. So this approach can be useful to investors and the financial analytics who want to data-driven decision support. So that's it. Thank you so much for your time and attention. So I will be happy to answer any questions.
Okay, nice presentation.
Thank you.
Yeah, I want to ask, how do you handle fake news or market manipulation in sentiment signals?
Sorry to say, ma'am.
How do you handle fake news or market manipulation in sentiment signals?
Okay, so if I talk about here as a sentiment analysis, so here I use a random forest for the decision making here. So in purpose of the fake news and the market, so you have manipulated informations as a stock markets, and we can say that we have a create a very panic or optimizations here. So we can say we have some strategies here we have follow here to avoid the reacting social media here, and cross check from the different types of news, we can say, and different type of websites.
Okay, thank you.
Thank you, ma'am. We'll proceed on with our next paper presenter. I'd like to call upon paper presenter Juhi Srivastava with the paper titled HASM Cloud, a hybrid adaptive security model integrating AI, blockchain, and FHE for dynamic access control in cloud environments. Ma'am, if you're ready, then you may start with the presentation. Ma'am Juhi? It seems she's not in the presentation yet. We'll proceed on with the next paper presenter, S. Ingavalle, with the paper titled Robotics for Inspection of Abrasion and Corrosion of Underwater Equipment. Ma'am, if you're ready, then you may start with the presentation. Yes, ma'am, now it is visible. Please go ahead.
Okay, ma'am. Okay, thank you, ma'am. Good afternoon, ma'am. Everyone, good afternoon. I'm Sheetal Ingole from Trinity College of Engineering and Research. Today, I will present my research work on topic robotics for inspection of abrasion and corrosion of underwater equipment. Our ocean, river, dams, for our economy. So, however, manual inspection of this underwater is dangerous, expensive, and extremely limited. So, this motivated us to design a low-cost underwater robot capable of performing live inspection, navigation, and anomaly detection. Here, I have presented my abstract for my paper. So within this, we have designed a low-cost underwater robot as we compared our robot system with the latest ROV techniques. We use IoT-based system in this process project. So which process, exchange, and receive all type of data. So the robot have been developed with improvement in the computer and information technology. We use IoT and RF signal model to achieve wireless communication. So next, introduction of underwater architecture. So our proposed underwater inspection system, it is designed as a multidisciplinary integrated platform. So basically it consists of four major components, that means robotic subsystem, embedded system, image processing subsystem, and IoT communication system. The robotic components, they are responsible for physical movement, navigation, stability of underwater robots. We design the robot in a such way that it remains stable underwater. It will resist water pressure and protect internal electronic components from the leakage. So the next one, the propulsion system, we use is DC motor with waterproof thrusters. The main purpose of DC motors to move the robot in forward, backward direction, left and right, and upward and downward direction. Next one is the embedded system or subsystem. Embedded system, it is the brain of the project. So we mainly consist of Arduino Uno microcontroller, motor driver circuit, sensor interfaces, power management system. So the Arduino Uno, it receives the control command from the user and then it converts that control signals into the electrical signals to drive the motor, camera and other module. So the coordinated movements of all motors, synchronization between camera and motion, safe power distribution to all components. So here we have you refer papers. So I have given the reference comparison of these all references. So we used 12 papers for this. Next one, it is a problem statement. So the underwater structures such as a platform, offshore platform, dams, bridges, and subsea cables, they operate in one of the harshest environment on the earth. That is, they are underwater. So these structures, they remain submerged for years and years, constantly exposed to destructive natural and chemical forces. So these are the five factors, major factors which affect the underwater systems. Then one is corrosive chemicals like dissolved salt, sulfates, chlorides, and other reactive components. When these components, they react with the metal surfaces, they gradually decrease, remove protecting layer from the steel. And this process we called as rust formation, pitting or cracking. Another factor, that is acidic fluid. The underwater pipelines, they carry oil, gas, chemical influence, industrial waste. When these fluids often have acidic properties, they also affect the inside pipes. They attack the inner walls of the pipeline also. Third one is the high speed sand particles. Underwater currents and even inside pipelines, water often carries small sand particles or small solid particles at a very high speed. When these particles hit the surface continuously, they behave like natural sandblasting. They remove the protective coating layer. Next one is the mechanical abrasion. It consists of rocks, debris, and floating objects. When they rub against the underwater structure due to strong current or wave, they constantly remove the protective layer from the steel or iron. Next one is the biofouling and debris. marine organisms such as algae, bacteria, shells, and microorganisms, when they attack themselves to the submerged structure, we call that process as a biofouling. So they increase the surface roughness, they traps moisture and chemicals, and then they cracks localized corrosion. So all these forces or all these factors, when they combine slowly but continuously weaken the underwater infrastructure, if we cannot detect damage at an early stage, they can lead to pipeline leakage, oil spill, collapse of marine structure, even environmental disasters also, and massive financial losses. So traditionally we use human divers, which are extremely risky, time consuming, very expensive and inconsistent. So all this concept, all these factors, they motivated us to design underwater robots which operates continuously, which is low cost, which is open source available, which reach deeper and more dangerous zone, which provide accurate and visual data, which reduce human risk and operational cost. Then objectives of our project, that is underwater robot. The main objective of our research is to develop an efficient, affordable, and user-friendly underwater robotic inspection system, which controls the limitation or which control the limitations of traditional robotic system. So here, first design of a wireless low-cost underwater robot. Most commercially available robots. Nowadays, we use the ROV, that is remotely operated vehicle robots or underwater guided vehicle, AGV, which are very expensive, complex, and require trained operators. So this limits their uses to large industry and research organizations only. So our project objective is to design a low-cost underwater robot which is easily available, open source hardware, and simple mechanical construction. Next, it provides real-time live video monitoring. So we use ESP32 cam processor, even though camera, which continuously capture underwater images and stream live video. So real-time video allows operator to observe the condition of underwater structure instantly. Even we identify visible cracks, corrosion, spots or abrasion, and we make quick decision during inspection. Third one is the detection of cracks, corrosion and abrasion. So another major objective is early detection of physical damage such as cracks, corrosion patches, and abrasive bit. When the camera captures images continuously, the system analyzes that images to identify abnormal surface patterns. Next, enable easy control through Android smartphone. So easy of operation, we focus on our design. We use the Android-based control system. The operator can control the robot using smartphone through Wi-Fi or Bluetooth. So the smartphone interfaces allows forward, backward, left, right movement, vertical motion for diving and surfacing, even live video display. Next, in the future scope, we use advanced image processing, artificial intelligence, and machine learning algorithm. Next one, it is the methodology. The methodology we used are, we combine robotics, image processing, microcontroller, or wireless communication, as I have said. Then we use camera, ASP Cam 32 processor continuously to capture underwater with the help of image analysis. Then detected data and images are stored. Scanning restarts if no damage is found. If you can't find any damages, the camera continuously captures the images of underwater objects. Even though we use Arduino Uno control motors, camera and system operations, then the robot, accordingly to that captured data, the robot movement managed by DC motors with program control, and we operated remotely using Android app via Bluetooth Wi-Fi. This one is the system block diagram for my research. Here we use mobile phone, Android smartphone, which is interfaced with the IoT module ESP Cam 32 processor. Here we use Arduino Nano, motor drivers to drive the motors, or robot upward backward direction. We use the relay to provide the proper supply to the system. Even the lithium ion battery, which is a lightweight battery, it has maximum capacity of 25 minutes to 30 minutes when it is fully charged. Hardware components in our robot. First is ESP Cam 32 module. So as I have discussed previously, we use ESP32 cam module, which is capturing underwater images, transmitting live video, enabling wireless communication, and storing inspection of data. So ESP cam continuously captures video from underwater environment and streams it in real time to operator smartphone. It uses the Wi-Fi or Bluetooth connectivity. The module contains built-in Wi-Fi and Bluetooth. Also, it is used for video transmission, command reception, and data exchange. Onboard memory, it has onboard memory. The ESP32 cam includes TF card slot, which allow captured images and inspection of data, which stores the images while it captures by the processor. Then L298 and motor driver module. L298 motor driver module is responsible for controlling DC motors. Since Arduino microcontroller, it cannot supply enough current directly to drive motors. So L298 acts as a power interface between Arduino and the motors. Then next one is the propulsion system. The propulsion system, it consists of 4 waterproof thrusters as I drawn in my hardware diagram. This thruster generates control movement of the robots in 3 dimensions. One is the forward backward, which we know horizontal navigation. The robots move in left and right direction. The depth control. Next, battery system. We use lithium ion battery in our research. So the robot is powered by lithium ion battery, which consists of high energy density, that it stores more energy in less space. It is lightweight. Then long operation time, 25 to 30 minutes per software used in our robotic system. Here we use Arduino IDE and C languages. So Arduino program handles it handles the motor control, camera activation, wireless command processing, and system coordination. Also we use C languages, which is efficient, fast, reliable, and well suited for embedded system. We develop a custom Android application using MIT App Inventor. So this application provides us robot movement control, live video monitoring, and system interaction. This one is the flowchart for our microcontroller programming. Here we use port C as the input and other ports as the output. In the main program, we define our camera to capture the video, even though it is interfaced with our web page. The user moves that particular robot in 4 directions. This one is the simulation for underwater robot. We use Proteus to check the simulation. Now, this one is the experimental result. After completing the design and developing the underwater robot, we conducted a series of experimental tests to evaluate the performance. Actually, we tested robot in 2 conditions, laboratory water tank, and second one is a shallow water environment. So live video performance analysis we have taken. So one of the most important performance factor of our system is live video streaming. Actually, we concluded all the data by the live video streaming. So because underwater inspection depends heavily on visual feedback, so we evaluated video performance under 2 main conditions, in clear water condition and in moderate turbidity condition. So in clear water, where turbidity, it is less than 10 NTU, in that case our robot achieve resolution of 640 by 480 pixels and frame rate 18 to 22 frames per second and end-to-end latency 220 to 300 times. So this means the video feed
Excuse me, ma'am. I'm
Yes,
really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, ma'am.
Yeah.
So the user with very small delay. Next, moderate turbidity. Moderate turbidity in moderate turbidity water, the turbidity between 20 to 40 NTU. Here we get frame rate 15 to 18 per second, and we get stable and continuous with navigations. So the navigation performance stable, we get stable navigation, then reliable inspection, real-time monitoring capabilities in our research. So basic advantages of my research. is low cost compared to commercial RV. This is our best advantages, and this one is the gap we overcome in the recent in traditional robots. So it has low cost microcontroller we use Arduino Uno, affordable communication module we use ESP32, even standard DC motors and locally available materials we use. It has wireless communication, so restrict robot movement as this as the cable. If we use cable, there's restrict robot movement. It limits operating range. It increase setup time. So all this can be overcome by using wireless operations. Then easy to control. Though this interface, the operator can steer the robot in all direction. It will adjust the speed and depth, observe real-time underwater video, and capture, store, inspection of data. Then portable and compact design, suitable for academic and industrial environmental use. Next is the future scope. This one is the best application we use in the future scope of our project. First is we are going to use sonar-based optical detection. Now, at the present, the robot mainly depends on visual feedback from the camera. However, in deep water or a highly turbid condition, our visibility becomes limited. So, in future, we plan to integrate sonar sensor, which use sound waves to detect object, measure distance, and underwater. Then AI-based corrosion detections. Currently, corrosion detection is performed through visual inspection. But in the future, we can integrate artificial intelligence and machine learning to classify defect types, to automatically detect corrosion patterns, to estimate severity. Next, higher capacity. Currently, it will work for 25 to 30 minutes. But in future, we can extend operating duration, allow longer inspection session, improve overall efficiency. So these are the references we used. Thank you, ma'am.
Yeah, very good presentation. No queries from my side. Thank
Okay,
you.
thank you, ma'am. Thank you.
Thank you, ma'am. We'll proceed with the next paper presenter. I'd like to call upon Prabhat Deshmukh with the paper titled Semantic Similarity Based Adversary Defense for Autonomous Object Detection. Ma'am, sir, if you're ready, then you may start with the presentation.
Yeah, hi. Am I audible?
Yes, sir, you're audible.
Yeah, I'll share my screen. Is this visible?
Yes, sir, it is visible.
Okay. Good afternoon, everyone. Today I will be presenting my research on adversarial defense for autonomous vehicles based on semantic similarity. So to give a brief background, deep learning has been the applications of deep learning like object detection and image classification have seen widespread adoption in various fields. Prime of them being sensory and perception modules in autonomous vehicles and various others like robotics and so on. But this gives rise to a lot of massive attack surface for adversaries, and one such attacks is called an adversarial attack, where the attacker perturbates or distorts an object as an input to the detector and leads the detector to misclassify that. So an example is in the slide here, where a stop sign is misclassified as a person by the detector. So this negatively impacts downstream decision-making services in the autonomous vehicle, leading to catastrophic incidents. So our design target is to make a defense that is detector agnostic and runs at inference time or at test time. So the attack also happens at test time. So we thought we will tackle this in the same place instead of going deeper and trying to optimize the model and so on, which is what a lot of the current defenses do. So, so our experiment, I want to brief about the experimental setup before I speak more about the approach. So we use YOLO V8 object detector to capture objects. Then we've used a COCO dataset to make benchmark embeddings, which we will be using for our semantic similarity. CLIP model is used for actually obtaining the embeddings. Offline trained MLP, so multi-layer perceptron, which is built on a combined feature vector, which can act as a binary classifier for whether or not it is an adversarial image or not. So yeah, moving on to the actual defense pipeline. So we run the object detector and embed what it outputs. So it outputs coordinates via bounding box and the actual classification. So we run this through the MLP first so that we can obtain the decision on whether it is or isn't adversarially perturbated. If it is adversarially perturbated, we perform semantic search via FIS library on the benchmark embeddings that I mentioned. So we can rectify it based on this, based on the output of that. So that is our basic pipeline. And these are just some of the results that we have, where we have a graph that agrees with our assessment, where if the object that is detected is actually semantically similar, that will be coming on this straight line here. If not, it deviates wildly. And so apart from our semantic consistency, we also consider two other indicators, which is temporal consistency and spatial consistency. So what I mean by that is if a particular object has the same classification for the previous n frames, it is temporally consistent, and that is not seen with adversarially perturbated images. So that's why we consider that. And spatial consistency means how many objects are actually detected. So in case of adversarially perturbated images, we see that in one frame it gives 3%, the next frame it gives 7, and later it gives 1. So this widely fluctuates across frames, successive frames. So this is another good indicator. So the basis of this is, of course, the semantic similarity itself. And the reason why we chose that is because even though adversely perturbated images fool the detector, semantically they're still similar to their original class. So what I mean by that is, even though this stop sign is distorted and fools the detector, semantically nothing has changed and it will still point to being a stop sign itself. So that was our philosophy. So that's what I've spoken of here in more detail. And yeah, so after this, we want to extend this to have three-dimensional perception and optimize the computation and latency, and also extend the benchmark more for making this more standardized. So yeah, that's about it. Any questions? Excuse me. Hello.
Yes, and that's a nice presentation. Just a
Yeah, thanks. Any queries? I'll be happy to answer.
Yeah, just want to ask, can you explain how semantic similarity is computed in your defense framework? Can you please explain that in detail?
Okay, so to explain that, so we first take a benchmark embeddings from the COCO dataset. So this will act as our ground truth for later applying FIS on top of this and performing semantic similarity. So we first take the various images in the COCO dataset and embed them, and later create indexes for each class using FIS. And later on, whenever we have input objects from the YOLO detector, we embed them as well using clip, and then compare that object with the benchmark embeddings. So that's how we do it.
Yeah, thank you.
Thank you. And before I sign off, I would like to extend my heartfelt gratitude towards SMARTCOM for actually giving me the chance to present. So thank you.
Thank you, sir. Thank you, ma'am. I'd once again like to ask for Ma'am Juhi, if you're here, then you may start with your presentation. It seems we do not have her, so this brings us to the end of the presentation. I sincerely thank our authors for the excellent work and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the publication will be live within 7 to 8 months, so kindly cooperate with the team of SmartCom 2026. I'd also like to thank our session chair for chairing this session. A token to the chair on behalf of team SmartCom 2026 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you. Thank you for this invitation. All the presentations were really very good. They have done a very good work, and that's. I mean, I have given some suggestions. They can incorporate those suggestions in the future. Thank you so much, all the participants and SmartCom team. Yeah.
Thank you, ma'am. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.